Hey guys, we are getting into chapter 3. We're going to get into some real algebra, which is going to be solving equations. And to be totally honest, because I'm not familiar with the middle school curriculum, I don't know if you've done this before. So we'll go through it day by day and pretty slowly, so hopefully you can understand what we're doing. So when you go about solving, you're trying to undo something. And today we're going to be starting with just one-step equations. And so we're going to be looking at what we call inverse operations. And inverse operations undo each other. So adding will undo subtracting and vice versa. Multiplication will undo division and vice versa. So that's how we know how to undo something. I always tell my students to ask yourself two questions. How is it attached? Meaning, how is the number attached to the variable? And then I ask them to think about, how do you undo that? So if it's attached with adding, you would undo that with subtracting. And if it's attached by subtraction, you'd undo it with addition. Same thing here. And then we get what we call equivalent equations. And that just means that they have the same solutions. Meaning that you're not changing it. If you add the same thing to both sides, it stays equivalent. If you subtract the same thing, it stays equivalent. So basically, it's like you're keeping it in balance. So let's kind of get a little look at what we're going to be doing. So we're kind of looking at the words in the algebra. So adding the same number to each side of an equation produces an equivalent equation, which is really hard to say. So what you want to know there is that it's okay to add the same thing to both sides. Now, throughout this note packet, they have it written side by side. For example, here it says, if x minus a equals b, then x minus a plus a, so they added an a on the left side of the equation. So we used to have on the right side of b, and we'd have to add a to that, because if you add it to one side here, then you have to add it to the other, because you're trying to keep everything in balance. But then what happens when you add and subtract an a? So if you have plus a minus a, those cancel out, and all you're left with is x equals, and then these didn't cancel out, so b plus a. So what we usually do in high school is we'll write x minus a equals b like we had originally. And then we kind of draw some tracks down the middle so that you kind of keep track of the two sides. And then if we want to add a to both sides here and here, instead of at the end horizontally, we see these cancel and we end up with x equals b plus a on the right. So it ends up with the same thing, but we just do it vertically rather than horizontally. So you'll catch me doing that throughout the notes and when we do examples. Subtracting the same number to both sides also produces an equation that is equivalent. So tons of big words to say that it keeps everything in balance and that it's okay to subtract as long as you subtract from both sides. So I'm going to rewrite this over here again. If you start with x plus a equals b and you're trying to get x alone because that's what it means to solve, you look and you say, like I had set up here, how is it attached? How do you undo that? So here the a is attached by adding, so the way you would undo that is by subtracting. And this subtraction property of equality says that that's okay to go ahead and subtract an a as long as you do it from both sides. A positive and a negative a cancel, and you end up with x equals, and then here they don't really go together and they don't really cancel, so you get b minus a. And that's where this was going. If you took away an a from the left side, you would take away an a from the right side. These canceled, and you'd get the same thing. I had b minus a. So here it says to solve an equation using subtraction. So this is what I'm going to do instead of all of this work in here, is I'm just going to show you off to the side how we usually do it. It's the easiest way. So if you start with this and you ask yourself, hey, how is this 3 attached? Well, it's attached by addition. So how would I get rid of it? I would have to use subtraction. So you kind of think of it that way. Then you can go ahead and take -3 here, but you have to do that to the other side to keep it in balance. So these cancel, and y would equal 10 minus 3, which is 7. And then you can check your work by going and saying, okay, I got that y is 7. So if I put a 7 in for y, does 7 plus 3, does that equal 10? And it is. So you can always check your answers to see if they're correct. So same thing, I'm going to put it out here on the side. And in this case, to get the t alone, I'm going to be asking myself, how is that -9 attached? Well, it's attached by subtraction. So I'm going to go ahead and undo that with addition. But I need to do that to both sides so that it stays equivalent or equal. So that on the left side, I just have t equals 11 plus 9, so 20. And then I can check by plugging in 20. Is 20 minus 9 equal to 11? And it is. Awesome. Okay, so go ahead and try these and then look and see if you are getting the right answer by checking with what I have. This will be what your homework looks like. And then keep in mind, you can always check, does what I got plus 6 equal 17? Yes. Does that equal 12? Yes. Now this one's a little tricky. You gotta keep in mind you're trying to get the x alone, so then the thing you're trying to get rid of is the 2, which has been added in. So you have to think about how you get rid of adding. And then here you have to think back, what is -3 minus 2 more? So you can use your calculator to make your life easier. And then you can also go back and check just to see, did you do that right? So every time you look at the number, like here it was a -4, so I ask myself, how's it attached? By subtraction. How do I undo that? By addition. And then here, -6 plus 4. So that goes back to the other chapters we've been working on. And just checking my answer. We practice positive and negative numbers so that when we're doing these solving problems, we actually can get the correct answer. Okay, so now we're going to basically go through the same thing and say, hey, you can do the same thing, and it can be multiplying each side is the same, and you're going to get an equivalent equation. So again, this is kind of writing it out side by side. I would say looking at it this way makes it easier for me to think about, because here, how is the A attached? Well, it's under a fraction bar, so it's attached by division. Whoops. Should probably turn that off before I start doing this. To get rid of division, I'd have to multiply, because those are inverse. So I'd multiply this side by A and multiply this side by A. This A on the top cancels this one on the bottom. I still kind of stay on my side of the tracks. So X will equal B times A. Here we're going to do the exact same thinking, division on each side. So basically our whole notes have been that you can add, subtract, multiply, or divide as long as you do the same thing to both sides. So here I'm going to start off with a problem that is AX equals B. How is the A attached to the X? Well, it's attached by multiplication. So the inverse operation of that is going to be division. So if I divide this side by A, and then I divide the right side by A, because I always have to do both sides, I would get X equals B divided by A. Okay, That is always more confusing than when it looks what it looks like as numbers. So let's take a look at this. So I'm going to do, again, copy the problem over here, and then I'm going to walk myself through the same thinking. How's the 8 attached to the x? By multiplication. So I need to divide both sides. The 8's cancel, and on this side I get a 7. I can go back and plug my 7 in to make sure that it checks off. Here I have a divided by 5. And so to get rid of division, I would have to multiply by 5 on both sides. These 5's cancel. One's on the top and one's on the bottom. So A would equal 12 times 5, which is going to be 60. Then I can check again. Is 60 divided by 5 equal to 12? And it is, so that checks. All right, so here we have kind of a combo platter. We have a fraction in front of the t. We have 3 over 5t equals 6. Now, in fancy math terms, we say that we multiply by the reciprocal. But what I always tell my students at school is, if you think of this as 2 steps, the 3 is multiplied by the t because it's on top. So to get rid of it, you would divide by 3. And then the 5's been divided because it's on the bottom. So we'd have to multiply this side by 5. But whatever we do to the left, we have to do to the right. And now 6 isn't a fraction, so it's easier sometimes to think of it if you write it over 1. Here, the 5's cancel top to bottom, the 3's cancel top to bottom, and I get just t. Here, I multiply the tops, I multiply the bottoms, and then I would reduce. And then I'm supposed to check my answer, so I would grab my calculator and I would take 3/5 times 10, and when you do that, you're going to get 6, because 3/5 times 10, which is over 1, would be 30 over 5, so 6. All right, so we're going to go ahead and check these, or go through these and try these. Again, you try them and then look and see if what you get is what I have. So I'm thinking in the first one, it's times 3. To get rid of that, I divide by 3. So here is my answer. Then I can check it on my calculator to make sure that it's true. Here, B is divided by 4. So I would have to multiply by 4. And then B is going to equal, what's that going to be? 4 times 3 is 12, 52. And I can go back to my original problem, take 52 over 4 on my calculator, verify that, yeah, that does come out to be 13, and feel confident about my answer. Now this one, the x is on the right side, but it's still multiplied by 4. So to undo that, I'll divide by 4, but I've got to do that to both sides, keep the math world even. And then on my calculator or in my brain, I would get -6. I could check, does -24 equal 4 times -6? And it does. All right, last one. This one has that kind of double action combo platter going on. And so I am going to, you can either go, oh yeah, you just use the reciprocal, or if that's confusing, just think of it in one step. This has been multiplied by a -3, so you'll have to divide by that. Then the m was divided by 8, so you'd have to multiply by that. But whatever you did to the this left side, you have to do to the right side as well. These cancel, these cancel. And so then I'm going to go ahead and take 21 times times 8, because those are both on the top, thinking of this as being over 1, and then divide that by -3, because when I multiply the tops, I get 168, When I multiply the bottoms, I get -3. And then when I divide those on my calculator, I get -56. Now that one's kind of tricky, so I'd probably check my answer. I'd go back up here and say, does 3/8 times -56 equal 21? And I would do that on my calculator and make sure that that's what I get, and that checks. So the big story on the whole section is really to just think about, what do I need to do to get rid of the number that's attached to the x? So keep asking yourself those two questions. How is it attached? And how can I undo that? And keep in mind that whatever you do, you always do to both sides. All right, so we're gonna check the daily plan for your homework and watch any parts of the video that you need to over again for any help.